Hello, this is Gary Marr of Glendale Community College. This screen capture is for my CIS 150 AB online students. And in this, I wanted to discuss and demonstrate a decision structure or an if statement block as promised, since I've already covered the repetition structure and the while loop with a student average example. This particular example does some discount processing. And essentially what happens with decision structures is you typically have one or multiple branches that the code will take based on a Boolean expression. So the book discount in this case is going to be 4% if it's 3 or more books, and all other purchases will be 1%. So I need to ask for the number of books, and I need to calculate the total cost and the discount. Excuse me, that's in the comment on top. That's the business rules required for this particular example. So I've got started my pseudocode. I make my declarations. Now, what I've decided to use in this one is use a couple of values, which will be floating point because it's dollars and cents. I could show this as 0.0 or 0.0. It's pseudocode, so really anything goes. I've also got one value here that's going to be numeric, starting at 0, and also another value of cost, which is going to be a numeric integer value of 10. I'm going to ask for the number of books as a prompt, and then based on that prompt, I'm going to do my if processing. If the book is 3 or more in quantity, then it's going to be true, this particular Boolean expression, so I'm going to take this true branch, which is going to return a discount, or set a discount of 0.04 in that discount variable. If it's not true, if it's false, so it would be less than 3, then it's simply going to give it a 1% discount. I next calculate the discount by multiplying the book amount times the discount. That'll give you the discount. And finally, I take the cost of 10, which is apparently the set cost of the book, reduce it by the discount for a total cost, and then display all 3 variables to the screen to show the user what those values would now be. In example 2 here, I've changed my code slightly to incorporate constants. Now, constants can also be what's called magic numbers. And what that means is this. For the immediate future anyways, I don't expect these discounts to change, but they might change. I certainly don't want my program to change them. I'm certainly not going to change them while this program is running. So for this run, my discount will be 0.01 and 0.04. Now, for some reason, later on down the line, these discounts change. I would change the constant value instead of having these numbers be hard-coded in my particular expression. So for example, up here, this is hard-coded in the expression. So if I'm going to change this value, I have to find every reference of discount, or at least the low discount and high discount, and make that corresponding change in it. If I create constants which correspond to low and high discount, I could actually refer to these constants numerous times in my program. It would always substitute that constant name for this value. Because of that, I reduce the amount or the potential for possible errors or defects in my program. It's a much safer, smarter solution. Show this to a potential employer, and they're going to be a lot more impressed than seeing a lot of hard-coded numbers placed throughout your code. Now, if you come down and look at the pseudocode for this example, really the only change that's being made is that I'm no longer putting the hard-coded discounted values. I now substituted it in for the high discount, low discount constant. So there's an example of if statements. And I also have a flow chart that I can show you of this code. And it has the pseudocode next to it. But if I was going to create a flow chart of this particular example, I would use a procedure block to show the assignments of all the variables. I would have my input for my books, my input symbol. My Boolean expression would be shown as a diamond, and the Boolean expression actually inside there. There's my false branch, there's my true branch, there's my final calculation, there's my displayed total. And all of this would roughly map the same as the pseudocode over here. In fact, I think what you're going to find is, in this particular example, I simply took the text from the pseudocode and placed it inside the symbol to describe what that symbol was doing. And that's fairly common. If you have any questions, please let me know.